So then we will enjoy the next talk from Constantin again, and he will show us something a little bit about Terraform. So before we saw the testing, now probably we see the execution, how Terraform could work or not. It will be really interesting. So give applause for Constantin and enjoy the next talk.
Thanks. Okay, now the picture's gone. That's not good. I'm not sure if that's my fault or... Oh, I have a mouse pointer here, so it is my fault. Ah, that looks better, right? You never know with technology. Okay, so wow, it's me again. I don't have to introduce myself anymore. I don't want to bore you. Just one point. I got asked about slides. I will share them over Twitter, and if on the webpage of the conference they will be shared, I will obviously also upload. Okay, they will be. Okay, so if you want to, you can download the slides there later. Okay, so we're gonna skip all that, and you already saw the picture. I reused the slide. So yeah, still working on infrastructure has changed a lot. And before we had also the timeline, and we saw that gap between when cloud came around and then when infrastructure as code tools like Terraform came around. So there is a huge gap. Even more so if you think that Terraform still has 0 versions, like they sort of don't say that is completely stable yet. So adoption is still in progress, right? And this talk here, we are going to focus on if we have existing cloud resources, like you've started provisioning stuff on your cloud, and now you want to have Terraform code for it, how to do that, and how to do that the smart way. This is basically what we're going to do. And it's going to be pretty technical because we will have to look at Terraform internals to understand how to figure that out. The problem is that you have support from Terraform to import existing resources, so you can do that, but it doesn't generate code for you, okay? So if you start importing stuff, you have it in a state and you can control it, but you cannot have the code for free. And this doesn't hurt much if you have 1 Kubernetes cluster or 2 databases or something like that. You just write the code, right? But what if you have like 100 of them or 1,000? You don't want to do that all manually, and that's what we're going to focus on. So the problem is, as I mentioned, you've started without Terraform, but you already have productive infrastructure that you don't want to throw away. Or maybe you've used a different tool, maybe you used the cloud tool like CloudFormation or the resource manager from Azure, and you want to move away from that. Or maybe you have sort of multiple code bases and you want to re-engineer your code bases and want to decide from scratch which resources belong to one code base and one state. Or you have done something different. Maybe you've lost your code base or your state file or whatever. Yeah, there can be many reasons that you have existing cloud resources, but the Terraform code is missing for that. So we are going to look at how to do that. Okay, for that, we are basically going to exploit some facts how Terraform does things internally. And to understand how that works, I want to just walk through how Terraform works in the normal way. And it's important that you understand the mechanism behind that, because we're then going to exploit these mechanics. Okay, so how does it usually look? Usually, you will write your infrastructure code in some Terraform code base. So you have a directory, you have a couple of Terraform files in there, and there you describe what you want to have, right? So you want to have databases and Kubernetes clusters and networking and everything. So this is your desired state. And on the other side, you have the cloud. Whatever that cloud is, it can be any of the big providers that you know. It can even be your own proprietary cloud as long as you have a Terraform plugin for that. So everything that I'm going to show you does not depend on any of the specifics. You can basically use that approach for any cloud provider that you have. what we need, of course, to do that programmatically is, again, some sort of API in front of that. Okay? So what happens, well, the rest of the slide is basically what happens if you run Terraform. So this is like a walkthrough through the process. So the first thing that happens is the code base that you have will be fed into Terraform, or Terraform reads the files and parses them. And I wrote the word provider here, so if you're familiar with Terraform, you know what a provider is. I kind of find that word misleading. It's sort of a plugin, so you have a provider for Azure, you have a provider for AWS, and the core logic actually is independent of that. So Terraform does the parsing, but then you have a resource that is specific to AWS, or a resource that is specific to Azure. And this is what the provider does, it handles those resources, okay? So we need that. The next thing that happens is that Terraform will update the so-called state file. The state file is like a file-based database or an index, sort of. It contains all the resources that you manage with Terraform. Okay, so if you start creating resources with Terraform, you will have an entry for that resource in a state file that contains an ID that identifies the resource uniquely on the cloud, but it also contains all the properties of that resource. So if you define a database, there will be, in the state file, you will have an entry to see how large the database is, like how much storage did you reserve, how many CPU cores, and everything, all the attributes are in there. And why does it refresh it? Well, it might happen that somebody changed something directly on the cloud. So you bypass Terraform and you change stuff on your resources. So for Terraform to decide what actions it actually has to take, it will refresh that state file so it has an up-to-date state of what's actually going on the cloud. And now we have sort of the Terraform code base on one hand, which is our desired state, and we have the actual state here, which Terraform gives us for free. And now it's both fed into Terraform, and then there's some sort of diffing going on, basically. Okay, so you can imagine if you have a resource in your code, but it does not appear in the state file, you've probably just created that resource in the code. So it's a new resource. It will be added. Okay, if it's the other way around, if it's in there, but you can't find it in the code, you've probably deleted that resource, and Terraform is supposed to delete it. Okay. If a resource appears in both, and they have differing attributes, then there will be an update operation. And if they are identical, completely identical, then there's no operation to do with that resource. Make sense? Okay, so what happens with all this output from that diffing is it goes into a plan file. So the plan file encodes the actions that Terraform has to take. And then with the help of this provider that basically knows how to talk to the cloud API, this is fed back into the cloud API, and then the changes are actually applied on the cloud. Okay, so this is the normal way of what happens when you run Terraform apply. And if you run apply directly, it will trigger that plan. There's also a plan command, but it will trigger it automatically in the background. Okay. Did you get that so far, or are there any questions? Because it's important that you understand this part. So if not, just shout, and we can clarify. So now we are going to reverse engineer that and kind of abuse this whole mechanism, or exploit, abuse is a strong word, to get what we want. So the first thing that we're going to do is we are going to take an empty Terraform code base. So we just create a directory and maybe some TF file, but there's no content, there's no resources. Okay? Next thing we do is we select some resources on the cloud that we want to have in the Terraform code base. So probably in your cloud subscription, you might have many resources, but only some of them should be in your Terraform code base because you want to manage them together. So you don't want to have all of them, you just want to have some. Then you need some kind of picking and need to figure out how to get them. And then we will import it into the state file. So for all the resources that we want to have, we now have an entry in the state file, but we do not have code for that. Okay? And if you now run Terraform Plan, what will happen is that Terraform decides, okay, I have lots of resources, but I cannot find any of them in my code, so I mark all of them for deletion, right? This is why we will never run this plan file against the API, because it would delete all our resources. This is not what we want to do, right? So we just produce a plan file, but it will never be executed. What we do instead is we read the plan file, and we figure out that in the plan file, there's not only all the resources that are supposed to be deleted, but also all their attributes. Because for some reason, Terraform spams them into the plan file, even though it might not really need them. Maybe some steps need them, I don't know. I don't know the internal stat that well. But it's a fact that for all the resources, all the attributes are in the plan file. So we can feed them in some small custom code generator and write the code back into our Terraform code base. Okay? There's something else that helps us generating that code, because generating code always sounds like a big thing to do, right? So this might be scary. It's not really that scary. If you there's another command for every provider in Terraform. You can get the schema, which is basically a huge JSON file where you can get all the information about the attributes. So for each resource, you can find what attributes are there, what nested blocks are there, what are valid values, and so on. So this is all stored in that schema, and you can also read that. And we also feed that in the code generator, and then it turns out this problem is not so hard after all. It's pretty easy to read out that schema and generate the code. Okay, so this gives us basically a migration plan. So the first thing we do is pick resources. The second thing we do is import them into the state file. And the third thing we do is generate the code from the plan file that we get here with help of the schema. Okay, and we start up there. Before I'm going to show you how that works, I want to show you what kind of things I use to do that. Well, again, like earlier, I use Kotlin and JUnit just because I like writing stuff with Kotlin. It's pretty easy. And with JUnit, I have the ability to run single methods, because I don't want to write a command line tool or some full-featured tool. I just want to do that one migration. So I'm not striving to build something that is perfect and covers all the cases. It's just to automate away all the manual labor. Do that once, and if I'm done, I'm probably going to throw that whole code away because I'm not going to need it anymore. So I just want to have something really simple, and with JUnit I can run single methods in my code, and that's actually all I need. In my earlier talk, you saw the one testing framework that we've built. We've basically interacted with Terraform via bash snippets. We are going to do the same thing. Communication between Kotlin code and Terraform is all via JSON. That's not beautiful, but it works. Like it's good enough. So I don't want to spend more time on figuring something that's more beautiful, because I don't need it that much. To do the data transformations, we use JSON Path, which is a library that you can well, it's sort of like, well, no, it's not. Maybe you know JQ. So this is basically a library that does similar things, where you can call it directly from Java. And we use lots of Kotlin built-ins to do transformations. Okay. Now merging the good and the ugly. We have Kotlin code here. So I've written that bash function. You can just provide some multi-line string. And this will be run by bash. And the output will also be outputted in standard out, so we can see it. There's also another version of it that captures the output. So if I run this, I get the return value, which is basically whatever the bash snippet outputs in a string. And what you have to be careful with is this is not a bash variable, because Kotlin has string interpolation, so this is the format variable from here. Okay, so if you want to have the bash variable, you would have to escape that $sign. But our scripts are not going to be that complicated. We won't need that actually. So these are the three helpers that I have: bash, bash capture output, and then there's a special variant of that one. It just parses the output as JSON and gives me maps and lists and stuff like that I can examine then. So it's not really much. It's a couple of lines of code written pretty quickly, actually. Okay, so let's go to step one. We want to pick resources from the cloud that we want to import into our Terraform code base. So it looks like something like this. I have lots of resources in there, but I only want to have these here. This is what I'm trying to achieve. And there are many ways how you can do that. You could go about and maybe do that manually, but this isn't fun for like thousands of resources, so maybe not so good idea. Maybe we can query a cloud API. So we just use whatever the cloud provides us to find resources and do that. Or maybe we have another infrastructure as code tool that has something like a state file that we can read out. It doesn't really matter what way we use. We can use the best way for us, what seems to be the simplest way to do it. In the end, what we need is resource IDs. So we need to import, to run the import command, we need the resource IDs, and that's it. Okay? And now I'm actually going to try and show you that. And I hope it works. Let me just... So, now let's close that. Okay, so let's try to do that. And live coding is always some risky business, but let's just try. So what I do is I write a simple test function in JUnit. And now I can do stuff like run bash snippets here. So I do something like AZ group list. So the example is going to be all with Azure. And what I can do now is I can run this code. And as I told you before, the bash function just outputs whatever the bash snippet outputs on standard out. So I can look in there now and I see, oh, OK, that's JSON. Nice. So let's maybe do that with capture JSON. And maybe let's actually filter that, because I don't want to have all the resource groups. So what I'm doing here is I'm listing all the resource groups that I have in my subscription, but I need some kind of identification to select them. So there are many ways to go about. I just do a really simple example and filter them by name. So I would just pick something like that. So I will unwrap the list. You see, this is it's probably a bit small. This is a list of resources. So I'll unwrap the list here, and then I use some JQ magic, and I just do something with regex here. I think it's called something like this, the one that I want. And then because I unwrapped it, but I actually might get multiple results, I will make a list out of it again. And now we have to do something small here, because we have to help Kotlin a bit with the types. Because what's the output is a list of map of string to any is the output. Okay. So these are the import RGs. And the nice thing, what I can do now is I can set a breakpoint here, and I can run this again, and I can look at what I actually get as a result. And I'm really sorry, I think I cannot zoom in down there, but maybe you can still read some part of it. So what I get here is, basically this is a list with one entry, and there's a hash map in there, and that's exactly the JSON thing that I get from the Azure command line tool. So I have now one resource group, it has an ID, and this is the ID that I want later. There's the location and all the attributes. And any of these attributes that you get here, you can also use for filtering or for selecting. So it doesn't have to be the name. You can take all resources that are in West Europe or all resources that are in North America, whatever. You can use anything that you get here to select. OK, so now we have a list of resource groups, but actually we want resources. So let's go on. Let's do resources, and now for every of the resource groups that I have above, I run another bash snippet, and that is basically resource list. So this gives me a list of resources that are in the group with a certain ID that I'm going to provide. So that will be the name. And again, I have to help Kotlin a bit with the types here, because this comes in all untyped. So that is a list of map of string any. Okay, and now we have to do something really important because this gives us all the resources that are in the resource groups, but we also want to manage the resource groups themselves with Terraform. Okay, so we have to add the resource groups again. And now we can debug that again and see what happens. Okay, now I have two variables here. The resource groups we've just saw, it has one entry, and then we have a resources list that has 4 items in there. And these are all the resources that are in that resource group plus the resource group itself. Okay, so this is everything that we want to import in this example. Now you can imagine you can do that with your large infrastructure. It doesn't really matter. The principle applies to, it doesn't matter how many resources we actually have. It's just the mechanism that I want to show you. Okay, so now we have like a JSON parsed hash map for all the resources with all the attributes. Okay. Pretty nice so far. What I'm going to do now is, instead of running this as a test, I'm actually making a real function out of it and just returning this here. And then the type is not right, but the IDE helps me with that. Okay, so we're all set for picking resources. These are my backup slides if the live coding doesn't work. So let's go back to that. We've done that here, and then we have a list of resources and all their IDs, and now we want to import them into the state file. Okay, this is the second step. So how are we going to do that? If we look at how the Terraform import command looks like, the thing that we want to run is Terraform import, and then we have to specify allow missing config. This is for Terraform to know that we don't have code for these resources yet, because usually it complains and says you are trying to import something that you've not written your code yet, but this is exactly what we want, so we allow it to be without the config. And then we have to do something like Azure RM resource group .name. So this is a Terraform type here. And this is a hard thing because we cannot guess that. So you have a MySQL database on Azure, but you don't know how the Terraform type is named for that. So we need to do some kind of mapping here. But you only need to do this mapping for each resource type. So if you have 2,000 databases, you only have to do this mapping once. And this is where it scales. And then comes just the ID. It's not more than that, okay? So what we are trying to do now is actually run this command for all the resources in our list. So let's create a new test function. Let's call it import. And before we can start, we need to set up a Terraform directory, right? I'm just going to throw that old thing here away. And we're also going to do that in the code, because if you want to retry the import, because something failed, we don't want to do that manually. So we will just create the directory and everything also in the code, that we can repeat the steps if we need to. So let's create some kind of working dir here, and let's put that in hacking tf. And the first thing that I'm going to do when importing is I'm going to delete this and then recreate it, so we always get a clean state, like everything is clean when we start the process. Okay. And now I have some helper functions here, so this will run everything that happens below inside the working directory, so it's basically like cd and bash. And another helper function for creating files, because what we're going to need is a file that is inside the working directory, and I'll just call it main.tf. And the content of that file is provider Azure RM. And now this is the first time I'm doing this with the provider version 2.0. They've just released, I think, a couple of weeks ago. So I think you have to do something like this now for it to run. I hope that works. So what we can actually execute it and see what happens, so it's easier and you don't have to believe me. This is really fast because it doesn't do anything, but we have now this directory and we have this main file in there, and that's exactly what I've just written, okay? So And every time I run this import function, it will delete the directory so we have the clean state again. So the next thing I'm going to do is I'm going to run a little snippet that does nothing but Terraform init, right? So we have an initialized Terraform. It will download the provider that I've just mentioned in the config file, and that's pretty much it. And the next thing we are going to do is, for all the resources that we get from the pick list here, we will run the Terraform import command. Okay, so I'm going to get import resources here from that function that we've written above. And this is a list, so I'm going to do something like for each. And I'm going to run a bash snippet for each entry. And now we're going to do exactly what I've shown you on the slide. So it's going to be Terraform import allow missing config. And now we have to do the mapping, because we have to tell Terraform the type and the name of the resource. And for that, I have a small helper function that I'm going to show you in a second. I'm going to call that with the ID of the resource. And with its name. Because we just picked the name from the resource as it is in the cloud. So let's have a look what this thing does. So this is the mapping that I was talking about. So what you put in here is the ID of the resource and the name. And what we'll do is pretty stupid, but it works, so why not? We just run through a couple of regex patterns, scan the IDs, and the Azure IDs always have something nice in here. They have basically the type of the resource in the ID, so we can use that to figure out which resource we have in hand. So if this is a DB for MySQL, so it will be a MySQL database on Azure, the result will be the Terraform type Azure MySQL Server dot its name. And this is exactly how we're going to produce what the import commands want from us. So this is the thing that you would have to write for all resource types if you want to do that migration pattern. OK, so we've called that. And then we need the ID again. And note that these line breaks here, they are in the Kotlin code. So this string interpolation, everything that happens between those parentheses is happening in Kotlin and not in the resulting bash snippet. So we don't have line breaks here in the bash snippet. And then we're just going to put the ID again. OK? So let's run that and see how many mistakes I've made. And what you can see here now is we are running Terraform init, so it will download the provider. Successfully initiated, and oh yeah, import successful. Okay, so the first resource is in there, and then the second. I've never read terminal output so low, so it's kind of unusual. And you see. One thing, the first thing that you notice here is this is not really fast, right? So this takes a couple of seconds for each resource, which is why I wouldn't recommend to do the whole import process in one big thing, because if something fails in a later step, you don't want to repeat that because it takes really much time. So I've kind of pulled out that step into its own phase of the migration. And now that I have a state file that I can use for code generation, I'm happy. And if the code generation fails, I don't have to run this again. OK, so if you look in the directory here, we will find that we have the main TF that I've graded, and we have a state file and nothing else. OK. And now I can run Terraform Plan, and just to show you what happens with the output. So it's going against my cloud subscription, and now we will see that we will get 0 to add, 0 to change, and 4 to destroy. And this is actually where I got the idea, because if you scroll up a bit here, you see that it marks everything for deletion, but you have all the attributes in there. So it has to be somewhere, right? And I just wanted to figure out how to access that. OK, so we can skip over that again. we've done all that. So what have we done so far? We've produced our shopping list, all the resources that we want to buy into our Terraform code base. We have an empty directory, we imported everything, and the nice thing is that from this point on, like this is everything cloud specific that we've done. Everything that comes afterwards is cloud agnostic, and I hope I get a bingo for that. And here the disclaimer, because some of the providers are a bit meaner than others. So Azure works pretty well. With AWS, we have some issues with the code generation, but I'm going to show you later or talk about it later. So now we are at the point where we've done all that and we have that plan file ready. The schema is easy to get, so let's start feeding that into the code generator. And I'm first going to show you the code and then explain you how it works. So the next thing we are going to do is write a new function, because this is a new phase for us. Generate. And I'm just obtaining some stuff now for the code generator. So the first thing that I'm going to do is I'm going to get the schemas. And I have a helper function for that, and you see it does nothing special. It's just another bash snippet, which runs Terraform provider schema minus JSON. Okay, this is all that's happening in there. So there's no magic going on or something. It's really simple. I have to run that in my working directory, and we want to pick a part of that. We don't want to have all, because the tree is a bit bigger than we want. We just want one part of it, which I have here. So this is JSON path again, provider schema. This is just a path inside the JSON that's interesting for us. And helping Kotlin with the types again. This is the type that we want in the end. Okay, and now we're going to do the same for the resource changes. I have another helper for that, and it's just as little magic as the other one. This runs Terraform Plan with an out parameter, and then it runs on this file that it produces. It runs Terraform show minus JSON, which gives you the plan as a JSON blob, basically, a huge JSON thing. And this should be resource changes JSON file. So this is just dot resource changes what we access. Oh, sorry, that was wrong. Here we need the working directory, and then we need JSON path, and the type is that. So it's a list of maps, and resource changes JSON path is that here. So it's really simple. Okay, and I don't have that much time, which is why you must allow me to copy some of it. I'm going to show you what we're doing here. Yeah. So what happens next? So in those variables, we have the schemas and we have all the changes from the plan file. And what we're going to do is we're just going to feed them into the code generator, which basically does for every change, it creates a generic configuration block, which is the class of the code generator. And what we feed in there is just the name, the resource change before. So in the plan file, you get a before and an after state. This is what you saw in the Terraform output before. So we just take before because there are all the attributes that interest us. And we put in the schema. We have to get out the specific part for the type that we're trying to generate. So every type in the schema has an entry in a big map, and we just get that type out and put that in the code generator. And then we just run the function resource code, which basically generates the code. So I'm going to trigger that. And in the meantime, we can have a look at how that code generator looks like. And it's a whopping 60 lines of code that you need to generate Terraform code with these inputs. Don't worry. I share that on GitHub, so you don't need to take pictures of that. You can get all that for free. I don't want to go through the code. I'm going to explain you how the thing works in a second. You saw the run was successful, so let's have a look in the directory. We now have a generated file in here. Okay, that looks a bit bad because you also have to run Terraform format, which I would do in the code as well. But, well, it's not beautiful written code, but it is nice. Now we have here Azure Kubernetes cluster. There's one resource. There's one resource for, no, where is it? Where is it? There is the MySQL server. And there's the resource group and the virtual network. That's all we have in there. This was all generated from that small code generator. And now, if you run Terraform Plan, it's really disappointing because you get errors. Oh, damn it. There's some things that you have to correct manually. For example, the provider has some, well, actually the state file contains some wrong values for max count and min count. Okay, let's remove them because they are optional actually. If you run that again, we still get errors, but those are really expected because the Azure API does not give us any passwords. So if we kind of refresh our state file, we will never get the MySQL password or the Kubernetes password. We will never get those. So they are missing in the state file, but this is easy to correct. Yeah, this is something that you can do. You have to think about how you do secrets management anyways. So whatever it is, what you do, just do it, put it in the Terraform code, and run and apply once, and then the state file will be up to date, and the plan will not yield any changes anymore. Okay, so I'm running out of time. I'm just wanting to show you what we've just done. So this is basically all the input that we have here with the state file, no code. Plan gets us a plan file where everything is marked for deletion. On the other hand, we get the schema file. We all put that in a code generator, and then we get the Terraform code base. Now the interesting part is, well, this is how you can make sure that you've generated the right thing when the plan comes up empty. Now, the interesting thing is, how does it work? How does the generator work? And what we have is basically two trees. If you're somewhat familiar with programming languages and how to parse them, usually this would be one tree, but in that case, it's two trees. We have the plan with all the actual code, well, all the actual resources and attributes. So there are resources, and that has an attribute, that has a nested block, and the nested block again has attributes. So this is the tree that contains all the values. And the schema tree is basically the type system of those resources, just it's externalized. You could annotate those nodes with that information, then you would have one tree. Just Terraform decided, or the HashiCorp decided to split those two things, so you have separate sources for the information that all actually belongs together. And the only thing that we do is we figure out, oh, this resource is of that type, so we put that together in the code generator. And all the rest that we do is we run along this tree. There's nothing else. It's recursion. Like we start here on the top, and then we get a resource, and then we produce that small thing that makes up a resource, which is the first line, like resource and type and name, and then the parentheses, and then the content. It's just recursion. We go over all the attributes of all the nested blocks and recurse, and that's all we have to do. And if you do that, it all sums up to the Terraform code that we want to have. So this is really not complicated at all. If you look at the code of the generator, those 60 lines, you will figure out pretty quickly how it works internally. So if we have an attribute at hand, the value is just JSON. So we use a JSON generator to produce the value. If we have a block, well, this is pretty much the same as a resource, it turns out. The only difference is that nested blocks don't have names, but resources do. So it's really just the same thing again. So we call the code for generating a resource again with recursion. Okay? So in the end, this is all a big post-order tree traversal, which you can, if you've forgotten from your days at the university or at your high school, just look that up on Wikipedia. It's nothing special. It's really simple. And that actually does the trick. So what have we learned? Resource import is pretty easy if it works correctly. So sometimes there are some issues with Terraform importing stuff, but this is not our problem to solve, right? So if there are bugs in Terraform, this is like a different problem. In general, the import should be easy. Mapping the types to Terraform types is cloud specific and is some effort you have to put in, but still it is not complicated. The code generator is like 60 lines of code, so it's not complicated either. Although you have to say that the quality of the output really depends on how well the provider is structured. For example, the AWS provider has a lot of conditional optionals. So it has like a couple of attributes, and some combinations work and some others don't. And it's not really nicely reflected in the optional required properties. So you might end up with not so good results. If the results are really bad, you can still write a dedicated code generator. So for each resource, you would have to write how it's generated, which is still a lot less work than to do all that manually, because you only have to write it once, and then you can reuse it for all resource instances. So in the end, if you have big migrations to do, this sort of scales, doing it manually will be very error-prone and take a lot of time. Some things I wanted to say before I come to the end is one important learning is semi-automate. So don't try to achieve perfection. It's a waste of time. Just do like semi-automatic, do some steps, and then if you have something, if you have the state file and it's correct, move on to the next step. Don't automate that completely. Yeah, so split import and code generation is the most important thing here. And that I already said. Don't try to build a tool. Just engineer the migration once and be happy about it. And that's it. Any questions?
Oh.
So I guess Terraform has the feature request to just integrate this feature. What's the state of those?
They actually have on their homepage, they have the information that they are working on or will work on having a full featured import command that automatically generates the code already, but they don't have a timeline, they don't have any issues in GitHub or milestones where I could see that this will happen soon, so I sort of like had to build it myself. Hopefully, at some point.
No, we can just upload it.
Sorry?
Altogether.
Sorry?
We can upload it.
Yeah, we should create the issue probably. Yeah, there's not even an issue on GitHub. I think. Yeah. That could be a first step to get that for free. Yes.
Yeah, but probably it's not for free, right? Because it's open source. You need to invest time, and time is the problem that costs a little bit at the end.
Yes.
So, but you can manage it. It's open source, if you want to.
True.
Yeah, so any other questions? No. Okay.
If they come up later, I'm still here, so just catch me.
Yeah, so we have still time around, so you can make small discussion afterwards. At 1 o'clock, lunch will begin again with some food, so I hope you will also enjoy this. And then we will see us back later at 2 o'clock for the next talk.
Thank you.